Hello everyone, welcome back. In this video we're going to talk about summary of array data structure, whatever we have learned. If you guys are confident about array data structure, so you may skip this video. So the first we are going to talk about definition of array data structure. An array is a collection of elements of the same type stored in contiguous memory location. Two things to remember while defining an array. Arrays can store elements of the same type. We cannot mix different types to store in an array data structure. Also, elements of the arrays are stored in contiguous blocks of memory. We saw that arrays are stored in contiguous blocks of memory. If the first element has 100 memory address, these are not real memory addresses. So the second element is increased based on the size of data type we store in our array. In this case, we store integers. So each memory location is incremented by 4. Also, we store only elements of the same type. All elements are integer type. If we have defined an array of integers, we cannot mix character here, a string here, or floating point here. All the elements should be the same. Second point we spoke about is array declaration. We use C#. In C#, arrays are declared by specifying the element type followed by square brackets. So the element type in this case is integers. We are defining an array of integers called names. This is the array nums. This is the array name. Okay, only declaring an integer called numbers or nums in this case. Okay, then we saw that how to declare and provide the size of the array. To do that, we use the type of value we want to store, then followed by square brackets, the name of the array, new int. Inside this square bracket we provide the size of array. In this case, size of array is 2. Then we spoke about array initialization. Basically we spoke about two types of array initialization: runtime and compile time. Array can be initialized at time of declaration or later using curly braces to include the initial values. Say I want to define an array called numbers, so using the curly braces I provide the values to store in my array. When I provide number of values, so the compiler will decide the size of array based on the number of values we provide. So in this case, I have provided 10 values, so the size of this array or length of this array is going to be 10. So this way we can initialize it at compile time, but we can also initialize our array in runtime. So say I want to take the values from user. Here I have defined an array of size 2, but I have not initialized any value to this array. To do that at the runtime, so I'm prompting the user to enter the first element. So using the console.readline, I take the user input. Since console.readline returns it in the form of a string here, so we gotta cast it to integer value using convert the toInt32 method, then store it back to numbers of 0. At index 0 I'm going to store whatever the user enters. Then I can prompt the user to enter the second element. Then once I took the second element, I can store it at the second index location or index 1. Then we spoke about accessing array elements. So array elements are accessed using their indices starting from 0. We saw that these are representing the index locations of each element starting from 0 going all the way to length -1. So in this case, the length of this array is 9. So we have 9 elements, and the last index of the last element is going to be 9 minus 1, which is 8. 9 minus 1 because not 8, sorry, 9 minus 1, which is equal to 8. We take it 9 minus 1 because we start from 0 and go all the way to end of the array indices. Okay, then we spoke about array length. The length or the size of array can be obtained using the length property. Say I want to access the length of numbers, so I can define a variable length and numbers name of array dot length property. It basically retrieves the number of elements in the numbers array. Then we spoke about multi-dimensional array. Specifically, we talked about 2D arrays or matrices. Arrays of arrays, multi-dimensional array are also called arrays of arrays, having rows and columns. In case of 2D array, such as 2D array, or also called matrix, if you want to represent data in a tabular or matrix form, we can use 2D arrays, or we can also have 3D arrays. We didn't speak about 3D arrays. If you guys want, I can make a separate video about 3D arrays. They're also declared using multiple sets of square brackets. For example, if I want to create a 2D array of 3 by 3 or a matrix of 3 by 3, I can use int. Inside the square bracket, I provide a comma denoting the dimensions of the matrix. So this is going to the first dimension, and this is the second dimension, row, number of rows, and number of columns. Then provide a name to our 2D array, new int of, in the case of single dimensional array, we provide only one value or one size, because single dimensional arrays have only one dimension, only one row. But in the case of multi-dimensional array or 2D arrays, we have two dimensions, we have row and we have column. That's why we have to provide the size for the number of rows. The first in this value is going to be the number of rows, and the second is going to be the number of columns. So in this case, we declare a 2D array with 3 rows and 3 columns. Then we spoke about dynamic arrays in the previous video. Dynamic arrays are implemented using list in C#. In Java we have array list, in Python we have list, or in JavaScript we have arrays. Unlike static arrays, dynamic arrays can grow or shrink in size using during the runtime, using the methods like add, remove, or resize. Say I want to create a dynamic array of type integer. I'm gonna call it list. Then using the add method, I can add as many items as we want. We haven't, unlike the static arrays here, we haven't specified the size of the array. We don't specify the size of array in the dynamic arrays. That's why we can add as many items as we want by just simply invoking the add method. When we add elements, so the size of array grows accordingly, but also when we remove elements, the size of the array shrinks accordingly. Then these are also generic data structures using this angular brackets. We know that these are generic data structure. We also implemented our own dynamic generic data structure array. So if I want to store string values, I can pass a string data type inside this angular brackets. If I want to store floating point, we can pass floating points, or we can also pass our own user defined data types. And then we spoke about array operations. Array supports various operations like searching or for element, sorting the element. We haven't spoke about sorting, also searching algorithms yet, but in the future videos we will talk about these algorithms in details. These operations are performed using algorithms specific to each operations. We haven't spoke about them yet, such as linear search. We spoke about linear search. When we search for an item in array using a linear search, it takes the time complexity of a linear search is going to be big O of n, or linear time. It depends on the size of the data set we have. As much as the size of the data set grows, that much the time takes to search for an item will grow. Then we have binary search. We will talk about. We have sorting algorithms like bubble sort or quick sort, etc. Then we spoke about time and space complexity a little bit. So each array operation has a time complexity which indicates the amount of time taken for an operation. For example, if we perform a linear search operation on array, it takes linear time, or a big O of n. We haven't also spoke about time complexity in detail, so in the future videos we'll talk about that. Then we spoke about array traversal. Array traversal refers to the visiting each element in array. It can be done using loops. We saw for loop and for each loop, or recursion to perform operation on each elements. So using for loop, we could access each elements of the array and process each element and then print it or whatever we want. Then we learned about how to traverse over the elements of array using for each loop. We give for each and var. If we don't know the data type of the values stored in our array, we can use var data type or variable data type. So item n number, so it will loop through the elements of the array, each time item will be equal to first element, second element, third element, up to end of the array. Then we can process that. We can also traverse array elements using recursion. I have defined a function. So recursion function basically are a specific type of functions that call itself. So I'm not going to talk about recursion in this video. If you guys want, I can make a separate video about recursion in details. So this function is a public static void, returns nothing. Traverse array recursively or recursive that takes an array of integer type, and then also an integer current index from where we want to start recursing. So the best case is going to be if current index is greater or equal to the length of the array, means once we traverse everything and reached the end of array, we return. So this is going to the best case. Once we hit this one, our recursion will terminate. Otherwise, we process each element, whatever we want to do. In this case, I want to print that. Then I will call this function inside itself recursively by passing the current index, incrementing it by 1 each time. So the current index is going to increment until it reaches the array length. Once it reaches the array length, so the recursion will terminate. So to call this function, let's go back to array traversal. We can call the array traversal method array. Oh, let me see this piece. Traversal recursive. Okay, this is static. We can call it inside the main function. Slicing traversal. So to call the recursive function, we can just call it and pass our array name. Say I want to traverse over the numbers. Then from index I want to start, so I want to start traversing from the first index. So it is going to recursively traverse over all elements of the array. Then we spoke about array slicing. So array slicing involves extracting a portion of an array by specifying a start index and length of the sub array. So say I want to subtract or extract items starting from index 2 going up to 5 elements, or the length of the sub array is going to be 5. So what first I can do is I can define a sub array or slice of the length whatever, how many elements we want to extract. Then using the array.copy, we can extract the number of elements or copy the sub array.copies. It takes like the source array, which is the numbers. So from numbers I want to starting from index 2, I want to copy elements to slice. Then the slice index starts from 0 and going all the way to length number of elements is going to be copied to the slice array. We also saw how to do it manually using for loops. If you haven't watched that, I recommend you watch the previous videos to see how we can extract a slice of array from a given array manually using for loops. Then we can output the slice array here using a for each loop. Then we spoke about array concatenation. Basically, array concatenation involves combining 2 or more arrays into a single array. In C#, we can use the concatenate method from enumerable class to concatenate arrays. Say I have 3 arrays, array 1, array 2, and array 3. I define a new array that is large enough as size of this plus this plus this, so I can use the concatenate. I pass array 2, then concatenate array 3, then finally I convert all the result to array using the 2 array method. So array 1 concatenate, array 2, and array 3. We can also do that manually using assigning one array to another array. So I have a loop here looping through elements of source array since they have the same length. So each time I copy the element of the source array and index I to the element at index I of the destination array. Then we spoke about merging. Merging 2 sorted array involves combining them into a single array. Say I have this two sorted array, I want to combine them, keeping the order of elements. So what I can do is I can create a new array called merged array, which has a size of length array1.length plus array2.length, so that a merged array is large enough to accommodate all the elements of array1 and array2. Then I define two counters or loop counters, index1 for pointer for array1 and index2 pointer for array2, and k2 pointer for merged array, to keep counting the index locations of the merged array. So using a while loop, I can merge the two arrays, also keeping the order of the elements. So while index1 is less than array1.length and index2 less than array2.length. So if I check if array1 at index1 is less than or equal to array2.index2, then I will copy the array1 at index1 location to merged array. Else, then I will, once I copy that, then I increment the index1 location. Else, I will insert the item at index2 of array2 to the merged array at index k location. In that case, I will increment the pointer of the array2 by 1. At end, for each loop, I increment the pointer for merged array. Or if we wanted to, if we don't want to keep the order, so first we can copy array1, then we can copy array2. We can do it using true for while loops, using separate while loops. So again, initialize these variables to 0, all of them. Using one while loop, I can copy the elements of array1. This is again going to be arr1.length. So merged array is going to be arr1 element of arr1 at index1 location. Then I increment index1 location, index1 counter. It goes all the way up to end of the index1 array1 elements. Then I also increment the pointer for the merged array. Then using second while loop, I can copy elements of the arr2, not array2. In this case, we have arr2 at index 2. Same case, we increment that. It goes all the way up to end of the arr2. Then at the same time, we increment the pointer for the merged array. So if we wanted to output that, we can do it using a for each loop. Then we spoke about array reversal. To reverse an array, we can use array.reverse method of C#. In this case, this array is sorted already. We can easily reverse it. We can also do it without using built-in function, without using this reverse method. What we can do is we can set two pointers, one pointer pointing to the first element and one pointer pointing to the last element, array length dot -1, because -1 we start from 0. So what we can do is one pointer, say this is pointing to the start of location or item at index 0. This is called left pointer or the start pointer, whatever you want to call it. Then one item start pointing at the last element of the array. Let's call it right pointer. So each time we loop, so we are going to swap these two items. So 9 comes here and 1 goes there. So 9 comes here, 1 goes there. Then we decrement the right pointer. Right pointer is coming here, and increment left pointer. So left pointer comes here. Next time we are going to swap these two elements. So 8 comes here and 2 goes here. All the way we go, we increment this right pointer, and we decrement right pointer and increment left pointer until they are equal to each other. So we also check while left pointer is less than right pointer. Once they are equal, this condition will be false and we get out of the loop. So during the loop, we swap two elements. So first we say and define a temp variable. Using this method, we can swap the elements. Then as we loop, we increment the left pointer, moving the left pointer to the right and moving the right pointer to the left. So finally, we can output the reverse array. So thank you guys for watching. Please don't forget to subscribe to Code with Cougar, and see you in the next video. Bye bye.